All right, so hopefully my little explanation of, whoops, I need to hit it at the right time. There we go. And hit it. Okay. Hopefully my little explanation of the weight related study helps to clarify in your mind what I'm talking about as far as always being careful about this third variable problem. The possibility that we're seeing two things as possibly causally linked when in fact it's a spurious correlation, and they're really only being associated with each other because of the presence of the third variable. But just in case that wasn't clear, I'm going to show you another example. Directionality. Sometimes we interpret the result as this variable in the correlation causing that variable in the correlation. Here's an example of something that we've known for a really long time. Here we have a little kitten, and he's looking at himself in the mirror and sees himself as a lion. That's so cute. That's what we call self-esteem, right? He's looking at himself and he sees himself as, scary and intimidating and all the good things that kitty cats want to be. Okay. We've known for a really long time in psychology that there's an association between self-esteem and then academic achievement. Now, notice I drew a little line that is a double arrowhead, because here's the thing. Those two things go together in a correlation, but what we can't seem to sort out is whether self-esteem is leading to achievement or achievement leads to self-esteem. We know they go together, but we can't figure out which direction any causality might be flowing. So if they are causally linked, we don't know in which way. One might be causing the other, but the other might be causing the one. So that we call that the directionality problem. Okay, so now keeping that in mind, I have some more examples from recent research. Okay, so research on kids and watching TV. So they were looking at 12 to 17-year-olds. And what they found is above the baseline that they called 7 hours per week. They apparently think 1 hour per day of television for 12 to 17-year-olds. Now, I'd like to point out for all of you who go, I don't watch any TV, any screen time is considered part of this study. So time in front of the computer for watching YouTube videos, watching it on your tablet or your phone, those all count. Any kind of passive watching stuff. Okay, what they found is once you got over the 7 hour per week mark, for every additional hour that the person spent watching a screen, there was a 2% increase in their obesity level for every hour that they spent watching the screen. Okay, so it's so easy for us to jump to a causal conclusion, isn't it? And think, well, duh, the more time you're sitting in front of a screen, the less time you're spending moving. Or sometimes people will throw in a third variable and say, well, yeah, when you're watching TV, oftentimes you're eating a snack that you didn't really need because you've already had dinner, and a lot of times the snacks aren't that healthy and things like that. But what about a directionality interpretation? Maybe kids who are more overweight are less likely to go outside and play with their friends or join a sports team or do the other kinds of things that would help to prevent them from being even more overweight. And so it's the overweight leads to watching TV rather than the TV leads to overweight. Those are the things that we always have to keep in mind whenever we're hearing a correlation, is that it's possible that some other factor would explain the existence of both of these things. How about a third variable being something like parental supervision? If you've got parents who work until 6 o'clock at night, and you get off of school at 3, you're home. Your parents have told you, I don't want you out roaming the neighborhood. I'm not home. Something bad could happen to you, so you stay in the house. And so, what do kids do when they're left alone and nobody's watching them? They eat and they watch TV, and they eat stuff a lot of times that they weren't supposed to be eating. Right? Because there's nobody here to supervise them. So maybe it's just about parental supervision and, whether the child has access to non-nutritive foods and a bunch of hours to do it. So it could be a third variable. It could be directionality. It could be that obesity causes how much TV you watch. It could be how much TV you watch causes obesity. Just remember those things. Okay. Last example of this. There's a correlation between how much ice cream is sold and then how many murders are committed in the area. So, and they go up nice and consistently with each other too. It's like as ice cream sales increase, so do murder rates. So I hope you're not coming to the conclusion we should outlaw ice cream because it obviously causes murder. Hopefully you're not coming to that conclusion. We should outlaw murder. It would reduce the ice cream consumption, right? Yeah. Let's not do that either. Because probably these two are moving together thanks to their association with a third variable. Here we have the third variable revealed, which is the month of the year. And as it gets hotter, ice cream sales go up. And as it gets hotter, murder rates go up. So we always have to keep in mind, third variable, I don't think that there's any directionality issue here. I don't think how much ice cream is sold determines what month it is. So I think the only interpretation we can come to is that these two things are going together because of a third variable, the time of the year. So I'm kind of belaboring this a little bit. Hopefully you got it, 10 minutes ago, but it's really attractive to hear the results of a correlational study and then think to yourself in a hindsight way, oh yeah, I can explain that. That makes sense because we explain it to ourselves and then we come to the conclusion that one thing's causing the other. And that's incorrect to do that. Now, having said all that, correlations, like I said at the very beginning of the first lecture in this chapter, correlations are the heart of psychological research. Pretty much every study includes at least something that is correlational. Even my research, which is very experimental, I tend to do at least an occasional correlation. So we have to use them. They provide a lot of valuable information that we can't get any other way. Sometimes we just have to see if two things that already exist go together or not. We can't make them happen. So the information that we get helps us to develop our hypotheses for maybe then trying to control things in an experiment. Because if two things go together, it's possible that one's causing the other. And let's investigate. Let's set up a study that would allow us to figure out if these two things cause each other, not just go together. Of course, if they don't go together, if we can compute a correlation coefficient and it's not significant, then we can skip the work that it would take to develop an experiment, collect the data, and then find out that they don't even go together, let alone one causes the other. So it's really useful to do correlations first. Gives us lots of valuable information. For some topics, it's the only way to study it because we aren't allowed to control some kinds of variables. Like, for example, I might want to do a correlation between the extent of damage that a person experienced through brain trauma. Maybe they were playing football or they were deployed to a war zone and they were near an IED or something like that, right? So I might want to look at the extent of brain damage and then maybe the score on an aggression scale or the number of times they've gotten into some kind of assaultive behavior or something. I have to use a correlation for this design because I'm not allowed to hit somebody in the head and give them brain damage to see whether that brain damage causes a change in their behavior. Right? I'm not allowed to do and then we're not allowed to do that. Hopefully no one would even propose to do that, right? Some things we can't study any other way except for to take pre-existing conditions and see whether they seem to go along with something else. So the thing is, we just have to be really cautious whenever we hear these kinds of results. I just really would like to emphasize, as good psychology majors, you probably will be smart and wise when applying this to psychological research, but maybe a little less confident when applying it to medical research. It's really important when you hear the results of a medical study on the news or you read it in the newspaper or on the internet or whatever, to remember that medical research is almost always correlational. And so you've got to be just as skeptical when you hear that researchers have found a link between how much soy you consume and your probability of developing breast cancer. You've got to be just as skeptical about that as you are about whether a person's traumatic brain injury is associated with aggression, or how many hours per day they play video games and then their rates of aggression. You've got to be skeptical about all these things because medical researchers also are not allowed to force feed you soy and see if it gives you cancer or not, or protects you from cancer. They're not allowed to do it either. And so in medical research, the experimental side of it usually is going to involve animals. The research that involves humans is largely going to be correlational. And so if you learn nothing else from this class, if you can learn to be a good, cautious consumer of the medical research that you hear on the news, your life will be blessed from having taken this class. So, all right. Well, that concludes correlational studies. So I'm going to go ahead and stop here, and we will reconvene in Chapter 6.